Hello class and welcome to today's lesson on 2.3 day 2. So for today, right, we're continuing on for our and or problems. So students will be able to calculate probability of and or. Our essential question, how do you calculate the probability of A from diagrams, right? Today we're going to jump into two-way tables and Venn diagrams and things. So to begin with here, right, we have this two-way table, right? It's diamonds, not diamonds, face card, not a face card. So right, we can see all the different possible cards in these events. And now we have some questions that we're trying to find, right? So what it's asking now is for the probability of these things. Very similar to how we did it when we were just trying to figure out how many there were, but now we got to figure out probability. And right, the key, a good way to think about probability is what you want over the total, right? What you want over the total. So if we look at probability of diamond, right? When we think of diamond, right, we're thinking of this column right here. So notice there are a total of 13 cards that are diamonds. And right, that would have been our answer back in chapter 1, but now what we're asking is find the probability. So we want diamonds, there's 13 of them, over the total of 52 cards. So right, if we take 13 over 52, we can reduce that down to 1/4. That's a great answer. Okay, now we go to the next one, right? It says probability of not a face card. Well, notice not a face card is this row right here. It wants to be not a face card, where there are a total of 40 non-face cards out of 52 cards, which leads to 10 out of 13. We reduce that down. Now our next one says probability of a face card and not a diamond, right? When it has and part in there, when it has two things, we're trying to see where do these things intersect. So right, face card and not a diamond, notice they intersect at this value right here. And so our answer for this one would be 9 out of 52. And the last one here, extend this a little bit. Right, probability of diamond and not a face card. So we look to see where do those intersect. Well, diamond, not a face card, intersect right here at 10. So 10 divided by 52. Which we can reduce down to 5/26. So right, doing a two-way table here, looking at the word and. Right, when we see the word and, it's right, just where do those intersect? Where do those intersect? So now, what if we have the question or? Right, notice same exact two-way table, but now the question is probability of face card or a diamond. And right, we learned about this formula yesterday. Right, probability of A or B is equal to the probability of A plus the probability of B minus the probability of both. So we need to do that same thing here. So right, I want probability of a face card plus probability of a diamond minus probability of a face card and a diamond. So what we're going to start with is, okay, total face cards. Well, face cards total would be 12 out of 52. Right? Diamonds total would be 13 out of 52. And then this is why we have to be careful. Notice when adding those numbers up, we counted that 3 twice. Right? That's really the probability of being both a face card and a diamond. So what we have to do is we got to subtract that piece, make sure we don't double count it. And so if we add these together, right, 12 plus 13 is 22. or 25, sorry, minus 3 is 22 over 52, which we then could reduce down to 11/26. Okay, similar type problem here, right? Diamond, but now this time we're doing not a face card. Right, we start with probability of a diamond, which is 13 out of 52. Then we add probability of not a face card. Well, that's 40 out of 52. And then we have to subtract the probability of both. Well, notice that comes right here, those 10 that we double counted. Notice in this case, if we did not subtract the 10, if we didn't subtract the stuff that we double counted, we would have had that the probability was 53 out of 52, which right away should make us think, well, that's not possible, right? It's not a greater than 100% chance it's one of those. So if we look here, we subtract, we get 43 over 52. Right, so we use this formula for both of those problems there. So you need to slow it down or pause it, just please do that. I'm going to move forward here. So now looking here, right, same thing. I'm going to go through these ones fairly quickly. Right, probability of male. Probability of male would be the total number of males out of the grand total, so 39 out of 92. Okay, probability of female would be the total number of females over the grand total. Now, this says probability of male or adult, right? So what we're going to do is we're going to take probability that they're a male. Well, we said that that was 39 out of 92. We're going to add the probability that they're an adult, which is 54 out of 92, and subtract the probability where they overlap, which is 24 out of 92, for a total answer of 69 out of 92. And then last one here, probability of female and adult, right? That's just where do those two overlap? Right, it'd be 30 out of the grand total 92. Right, and we'd reduce those as we do that. So now moving on to a Venn diagram. Right, looking at this Venn diagram. Venn diagrams actually make our lives a little easier to answer some of these questions. So notice to start with, what's the probability of a face card? Right, probability of a face card, we'd count up everything that's inside of this circle. And if we do that, you'll notice that we get 12 out of our 52 cards. Okay, now our next one is asking for the probability of a heart. In this case, I'd take everything added up in that circle, which would be 13, right? These 11, or these 10, sorry, plus these 3. And now notice these questions, right? This is where it makes it a little easier for us, right? Probability of a face card and a heart, right? For this one, we're just focused on what's in the middle here. And so in this case, it's 3 out of 52. And now this is the key piece right here. When dealing with a Venn diagram, this is a little different. Notice with a Venn diagram, we have already taken that middle piece, the double counted piece, and put it as its own value. And so just like we did when we started with Venn diagrams in chapter 1, to find this answer, we just take whatever's in here, plus what's here, plus what's in there. So right, if we deal with face cards that are not hearts, there are 9 of them. 3 cards are both a face card and a heart, and 10 cards are just a heart. If we are to add those values up, we get 22 out of 52. So notice Venn diagram's a little different than 2A tables when dealing with the question 4. dealing with the question for. So let's try another one here, right? This should be a familiar Venn diagram. So looking here, probability of A or B, right? This is A or B. We just talked about this, right? We add these three values together, and we get 174 out of 178. Right? Next one, A and B, right? This is just where do they intersect? That's just going to be this middle number. So 19 out of 178. And then thinking back to this notation, right? Since it's my last problem, I'm going to do this. We want not in A, right? This is saying not in A. A is this circle right here. I want not in here. So I'm going to get rid of everything there. And I want to add up whatever is left over. Notice that's 71 plus 4, which gives us 75. And this is not correct. So 75 over 178. So a couple more quick examples. Looking here, right, again, we've seen this Venn diagram before. So going through this real quick, right, A or B, right, we're adding up these percentages. This would get us, right, 30 plus 5 plus 15, 50%. Right, when we think about probability, since it's as a percent, we're already good to go. If you really wanted to think of it, right, 50 over 100, but right, percentages, we can just write as such. So 50%. Right, this is A and B. We're just looking for where do those intersect. This one would just be 5%. And last one here, not in A. Well, A is that they read USA Today. We get rid of that. We add what is left over, 65%. 65%. So that is it for today's lesson on 2.3 day 2. Right, dealing with and or in both Venn diagrams and two-way tables.